Okay, here are the examples we left off with at the end of the last lesson. As a reminder, these are the note sheet 4.3, 4.4, Bronsted-Lowry acids and bases. I had done 1 through 3 with you and left you to do number 4 and number 5 on your own. Take a moment to check your answers, please. Okay, the new portion of today's lesson is called amphiprotic substances. Something that is amphiprotic can act as either an acid or a base. So an example is, if you go back up to question 4 and 5 here, HCO3 minus in question number 4 is an acid, and HCO3 minus in question number 5 is a base. This is an example of something that is an amphiprotic ion. So how it will act in an acid-base reaction will depend on what the other ion is doing. Water is also an example of an amphiprotic ion. Water, most of you can remember, can be written as HOH. Okay, that gives us the opportunity for it to donate an H when it's acting as an acid, and it gives an opportunity to accept an H when it's acting as a base. This is another example of an amphiprotic substance. Below, I've written you some equations that are amphiprotic. They start with a polyprotic acid. So to be a polyprotic acid, you have basically H2 or H3 at the start of your acid. These are the 3 most common ones that we use in Chem 12. They are sulfuric acid, carbonic acid, and phosphoric acid. When these acids ionize, I've written the endings for you in red. The ion that they form, which I'm just re-underlining for you here in green, are amphiprotic. The way you can recognize an amphiprotic ion is that it has an H, which means it can donate it, that makes it an acid, and it has a minus sign, which means it has a little bit of room that it can take an H onto it. So if you look for a minus sign, it usually means the base can accept an H+. Okay, so in the box here, I've highlighted you 2 ways to check for an amphiprotic ion, and you need to look for both. Okay, you want it to be both an H and a minus charge. Water is an amphiprotic ion, even though when it's written as H2O, it's kind of invisible, but if you write it as HOH, you have H plus indicating your acid and OH minus indicating your base. Okay, for a quick check, we're going to circle which of the following of these are amphiprotic. I'm going to practice pausing my video and see if you can complete it. Okay, here we are. I've circled in highlighter our amphiprotic ions. The ones that I have chosen have both an H and a minus sign, so hopefully you picked those 4. Before we go on, let's just take a minute to talk about and identify the other ones. So for example, SeS2- has no H to give. This guy is automatically a base. H2Se has an H already, so that makes it an acid. H33O4 is likewise an acid because we can see it's H. PO4 minus has no H, so it's a base. And H2SO3 is an acid. The ones that I have labeled in red above, acid and base, are ones that you should be now able to recognize can only act as an acid or can only act as a base. Okay, now how we form an ion that is amphiprotic, I'm going to fill these in with you and explain to you what you get as an ion to tell if it's amphiprotic. So for example, HCl, if I split this up, I'm going to get H plus and Cl minus. Neither of these are amphiprotic. The ion has to have an H and a Cl together. Same with HNO3, so I would have H plus NO3 minus, so this is not amphiprotic. Now, when I get to H2SO4, I can only split off one H at a time. So that leaves me with H plus, that's my 1H, plus HSO4 minus. Okay, this is an example here, the one I'm putting into the green box. This is an amphiprotic ion, as it has both the H and the minus sign. Same with H3PO4. Again, I can only split one H, so I'm going to take away one. So this will be H2PO4 minus. Oops, that should be H plus HPO4 minus. There's my H. Here's the rest of my ion, H2PO4 minus. Okay, and again, this guy here, also amphiprotic. And H2PO4 can actually ionize off another H as well, so I can take an H from here and make HPO4 2 minus, which is also amphiprotic. So the phosphoric acid actually has two ions that become amphiprotic when it is made. We're going to finish today by doing a little bit of practice of you writing conjugate acids and conjugate bases. I will do the first couple of them with you, and then we'll pause the screen and you can try to do a few on your own. So my question has, write the conjugate base for HSO4 minus. Well, your first thing I think I want you to recognize is that this guy is amphiprotic, which means I started you out with a difficult one. If it's amphiprotic and it wants you to write the conjugate base, it means that this is an acid. So I'm going to label this entire column acid so that we remember. So amphiprotic, but the question tells us that it's going to be an acid. Okay, so the next thing we really need to remember is that acids are proton donors. Okay, to write its base, Cb conjugate base, we're going to take away one of its H's. Take away an H. And I'm going to remind you, it's an H plus. Okay, so in this case, if I'm going to write my conjugate base, I'm going to take off the H, which is going to leave me with HSO4, 2 minus. So when we take away an H, we're also going to add a negative onto it. So HSO4 already had 1 minus. Okay, and now I've changed it to 2 minuses because I've stolen its H, and when I stole its H, I also stole its plus sign. Okay, this one here, HCO3, this guy can only act as an acid. It doesn't have a minus sign, so I know that I'm just going to give away its H. I like to show that with a little arrow of the H disappearing. This makes this HCO3 minus. That's the conjugate base. You will notice that one is amphiprotic, but that does not change the answer to this question. CH3COOH, this guy here is an acid. This is acetic acid. We've talked about this one before. This is the most easily removed H. So remove this one. Okay, when you get an organic acid, the H that's on the end is always the one that you split off. So this becomes our acetate ion, which you should recognize, CH3COO-. Usually for your conjugate base, if you make an ion that you recognize from the back of your periodic table, you've probably done it correctly. NH4 plus, this guy's got an extra H, so this one, if I take an H off, it just becomes NH3. That's the conjugate base form. That is ammonia. We'll learn to recognize that one as a common weak base. And I'll pause now and let you try the other few on your own and come back to them. Okay, and there's our last three finished. The last one should be PO4 minus 3. It's not written all that clear. There we go. And as you can see, again, some of these should be ions that you recognize from the back of your periodic table. Okay, the next question is going to ask us to write conjugate acids. All right, again, I'll do the first ones with you. I started you out with an ion that is amphiprotic. Okay, this question tells us that we want to write the conjugate acid, so that's what I'm going to label my column here, which means these are automatically bases. That's because the question told us that. Because they're automatically bases, they are going to accept protons. So a base is a proton acceptor. Okay, so to write your conjugate acid, you're going to add an H+, and if it has a minus, you're going to cancel one of them. Cancel one minus. Okay, so we'll do a couple examples of that. So starting with H2SO4, it's going to accept a proton, which means it's going to become H2SO4. And my rule said I can cancel one minus, which is this guy, because I'm adding an H+, so the plus and the minus cancel, and I have no charge written up here. Okay, SO4 2 minus is going to take an H, so HSO4, and I'm going to cancel one of my minus numbers. So instead of 2 minus, I'm only going to have -1. Now, NH2 is one you haven't seen before. It pops up occasionally. If it's going to accept a hydrogen, accept a proton, it will become NH3. Okay, again, here comes ammonia again. As you can see, this is a fairly common weak base that we use regularly in this unit, so it's important that you start to recognize it. NH2 minus is actually quite the rare form of ammonia. We usually see it as NH3. And in our next question, we're seeing as NH3. It's acting as a base, so it means it's going to take an extra H+, and it's going to become NH4+, which is the ammonium ion. Okay, so these two, NH3, NH4, these are very common. Okay, so I want you to be able to recognize those. And again, NH2 minus is rare. You're not going to see it very often. And I'll pause the last video, the last two, and you can try them on your own. Okay, and I filled in the last two for you. Now you have everything that you need to go ahead and complete the worksheet that I've given to you. You will find it on the website. And the worksheet that you should be able to complete now is worksheet 4.1 to 4.4. So it covers all of these information as practice. Okay, that's it for this time, and I'll bring you up the next lesson on conjugate acid and bases next day.